All right, today we're going to be talking about distribution and word problems. We're still solving equations, so that's still going to be part of what we're doing today, just like we did last time. You're going to work through this exact same worksheet with me for your notes and keep this with your notes after we get it all filled out. And then you do have an assignment over this tonight. You are expected to know this material when I see you next. So make sure you take good notes, pause and go back if there's anything you're not sure about and that you need to see again. All right, make sure your name is here at the top. Okay, and then let's take a look. We're talking about distribution, and we've seen some distribution problems before, and we know that when there are parentheses in a problem, we know that's when we must distribute. Okay, so let's fill this in. Anytime we see parentheses in a problem, the first thing we want to think about is distribution. All right, then we're just going to follow our old process for solving equations that we've done for a long time now. All right, so let's look at this very first one. I see this 3 outside parentheses. I'm going to distribute. 3 times positive 2x is 6x. 3 times positive 1 is positive 3. And now I just have this equals 21 here that I need to drop down to the bottom. All right, and now I'm following my steps. I see I'm multiplying by 6. I'm also adding 3. We deal with adding and subtracting first. All right, so I get 6x equals 21 minus 3, which is 18. Okay, you can use a calculator if you're not sure about some of those problems. Now I see multiplication, so I know the inverse of that is division. So I'm going to divide both sides by 6, and I get that x equals 3. I still could take this 3, plug it back in up here for x, and make sure that it works out. All right, 2 times 3 is 6, plus 1 is 7, and then 7 times 3 gives me that 21. So I can double check my work and make sure that I'm getting it right still. Okay, it looks like our problem numbering is kind of funny. So we go from A, we'll just jump down 1, even though it says E, that's kind of strange. All right, so here we see that the variable's over on the right-hand side, but that's okay. We still see parentheses. We have a number outside the parentheses, so we know we're going to have to distribute. All right, we have negatives here, so we're going to be very careful and take our time. Negative 4 times positive 5x is negative 20x. All right, and negative 4 times negative 7 is positive 28. All right, we still need this left-hand side of our equation, though. We need 128 equals this. All right, now again, we just have a nice two-step problem. I see adding 28, so I'm going to subtract 28 on each side. All right, 128 minus 28, that's easy. That's 100 equals negative 20x. All right, be careful, don't lose any of those negative signs or anything like that. Now I see it does have a negative in front of it, but it still is multiplication happening here. So I'm going to divide both sides by negative 20. All right, 100 divided by negative 20. Use a calculator if you need to, but this comes out to be negative 5. And over here I'm left with just x. Okay, so negative 5 equals x. All right, continuing on down the page here, we have another one. This one's kind of weird. There's no number out in the front, and we've talked about this before. When there's not a number there, what really is there is a 1. So it's like a negative 1 outside the parentheses. So we're just multiplying each part by negative 1. Negative 1 times x is negative 1x. You can put the 1 there if you want, or you can just make it negative x. That would be okay as well. Negative 1 times positive 5 is negative 5 or minus 5. Equals 13. All right, again, I have a nice little two-step equation. I see subtracting 5, so I'm going to add 5 to both sides. So this is negative 1x equals 13 plus 5, which is 18. And now I need to divide both sides by negative 1, or what this basically means is just change the sign of both sides. So this becomes x equals negative 18. Again, we could take these numbers, plug them back into the original problem, and make sure that they work. All right, the next set of problems get a little bit trickier, but not too much. All right, again, I see that I have a number outside parentheses, which means I'm always going to distribute first. And anytime you see parentheses, that's what we're thinking about, distribute first. All right, here I'm going to distribute this negative 2. Negative 2 times 4x is negative 8x. Now I'm going to distribute to the negative 1, so negative 2 times negative 1 is positive 2. I don't distribute to this 3. This 3 is not inside the parentheses, so I'm not going to distribute to that, but I am going to drop it down into the original problem, or into this next step of the problem. Now what's different about this one, over here when we did problems, we just ended up with 2 steps at the end. We had a multiplication and an adding or a subtracting. Over here I've got some more stuff I need to clean up before I move on. I see that I have like terms. I have 2 constant terms on this side. I can combine those into one term so that then I can have a nice two-step problem. So my negative 8x just drops down. And here I just see I have 2 plus 3, so this becomes plus 5 equals negative 11. Now it's a nice two-step problem. Minus 5 on each side. Negative 8x equals negative 11 plus negative 5, which is negative 16. Okay, divide both sides by negative 8, and x equals 2. Okay, you do need to be showing all your work on these problems, so please make sure that you are showing all your work. If you haven't done that, you're going to need to go back and do that. I'm going to be taking a look at these notes to make sure that they are completely done when I see you next. All right, H has a fraction in it. We always freak out about fractions. They're always a little bit scary, but we've got calculators, right? So all we're going to do is get our calculator out and make sure that we can type these things into our calculator and we can get the right answers. All right, so we're going to distribute 3/4. 3/4 times 2. All right, in my calculator, I type that in as 3/4 times 2, and I get 1.5 is what my calculator tells me. That's a nice decimal, so I'm going to go ahead and just use it as a decimal here. So 1.5x. All right, and then I'm going to do the next part. 3/4 times negative 8. So 3/4. And you would type this in your calculator however your calculator does fractions. So 3/4 times negative 8 actually comes out to be negative 6. I'm just going to write minus 6, and then I still have equals negative 10. All right, we've got some decimals in our problem, but that's okay. We see we're going to have to add 6 to both sides. So 1.5x is negative 10 plus 6. Negative 10 plus 6 is negative 4. All right, and then I'm going to divide both sides by 1.5. All right, hopefully you're working ahead of me maybe just a little bit here. You've already done this, but let's type that in our calculator. Negative 4 divided by 1.5, and I get this big crazy decimal, which means definitely I do not want to give the answer as a decimal. I want to make sure that I give my answer as a fraction. So our x here equals negative 8/3. Negative 8 over 3, which if your calculator does different formats, this is the same as negative 2 and 2/3. Okay, either of those would be acceptable answers. The decimal is not an acceptable answer. All right, this last one that we have with distribution here has decimals in it. So let's take a look at what this does. Again, we're just going to be using our calculator though. Okay, 0.02 times 3.74 is 0.0748, it looks like. All right, 0.0748x plus, and now we're going to do this part right here, 0.02 times 1.2, which is 0.024, okay, equals 1.96. All right, these get a little bit weird looking, but they're not too bad, right? We've got calculators to help us out. We're going to subtract 0.024 on each side. Okay, so 1.96 minus 0.024, and we get 1.936. And on this side, I still have my 0.0748x. Okay, I'm going to divide both sides by that, 0.0748, 0.0748. Showing our work when we have problems like this is really important. So 1.936 divided by 0.0748. All right, so we're seeing who can pay attention to details. We're going to go to 2 decimal places here. So 25.88. It is a decimal problem, so I'm okay with a decimal answer rounded off. All right, so x is 25.88. Okay, so decimals and fractions, even those are not too big of a deal. All right, one last one here that's kind of a word problem that has to do with distribution. We can see here, this one says the formula for perimeter, okay, is 2 times the length plus the width. We're being told that the perimeter of this shape is 48. So we want to solve for x here, and we've got length and we've got width. We can see both of those things drawn on this rectangle. We're going to use this formula. Perimeter equals 2 times the length plus the width. Well, now we just need to fill in the things that we know. All right, we know the perimeter. The perimeter is 48. All right, 2 is just a number, and now let's see. The length, and it doesn't matter which one you call length and which one you call width. I'm going to call the length 9. 9 plus the width, which is 5x. Okay, and we're supposed to solve for x. So we've filled in all the things we know. Now we have a nice little distribution problem. I need to distribute that 2 to the two numbers inside. So 48 equals 2 times 9, which is 18, and 2 times 5x, which is plus 10x. Again, we've got a nice little two-step problem, minus 18 on both sides. Okay, so this is 30 equals 10x. Divide both sides by 10, so we see that x equals 10. Okay, whoops, I'm sorry, you can't see that part. Or x equals, and you know what? I just made a mistake there too. I was working too fast. X doesn't equal 10. 30 divided by 10 is 3. X equals 3. All right, so make sure you made that fix if you were paying attention to my mistake there. All right, so we can do some word problems even with our distribution here. All right, talking about word problems, let's take a look at some translations and some word problems. So you're flipping your paper over to the back, which looks like this. All right, we've done problems like this where we translated expressions. Now we're going to be translating equations. So we talked a lot about how expressions versus equations. Expressions don't have equal signs. Equations do have equal signs. We did talk about all these different operations and all the words that might go with those operations. But now we need to add one more really important word so we can translate equations, not just expressions. The word is means equal. All right, so anytime we see the word is in a problem, we know that's where the equal sign is going to go. All right, so let's take a look at some of these translations. We are going to write an equation and we're going to solve it here. Well, first of all, I see the word difference, which I know means subtract. All right, and then we know the a number part is x. All right, so the difference of a number and 9 is x minus 9. And now we see this special word is 20, equals 20. All right, so we're just making our translation. Now we also need to solve this, so we're going to add 9 to both sides. So x equals 29. Okay, so you're going to do the translation, you're going to write it out, and then you're going to solve it. All right, so 2 times a number, this is x right here, plus 5. So 2 times a number is 2x plus 5. And then here's our is equals 25. All right, now we have a nice little two-step problem. Minus 5 on both sides, so 2x equals 20. Divide by 2 on both sides, so x equals 10. All right, please make sure if I'm going too fast for you on any of these, that you go back and re-watch the problem and make sure you're really getting these. All right, quotient is kind of a funny word, but we can see up here quotient means divide if we weren't sure about that. So the quotient of a number and negative 4 is 16. So x divided by negative 4 equals 16. All right, we know that the inverse of divide is multiply, so we're going to multiply both sides by negative 4. So x equals, and I'm not sure actually what 4 times 16 is, so I'm going to go to my calculator. 16 times negative 4, and I get negative 64. Okay, so use your calculator anytime you're not sure about those answers. All right, one more translation. 4 times the sum of a number and 1. We remember that the sum of a number and 1 needs to go in parentheses. That's x plus 1. And now it's 4 times the sum of a number and 1 is 16. All right, this one we're going to have to distribute. 4 times x is 4x. 4 times 1 is 4 equals 16. We'll subtract 4 on each side. So 4x equals 12. Divide both sides by 4, so x equals 3. Okay, so remember some of those trickier translations. When it says the sum of, that part has to go in parentheses, and that's going to be a distribution problem. All right, down here at the bottom we have some more just traditional word problems. Now here's the deal with these word problems. These are problems that you probably don't need to set up an equation to solve. You probably can solve these just fine without writing an equation, but we're going to practice writing equations for these anyway. So what I say here is for step 1 is figure out what the answer should be. You can probably figure that out without writing an equation, without doing any algebra. But we're going to then define a variable based on what we don't know, and we're going to write or choose, if it's multiple choice, an equation that gets us to the answer that we know it should be. Okay, so let's read this and let's talk about it. All right, so Mike, who has 6 video games. So Mike has 6 video games. He has 2 times as many games as Paul. So Mike has 6. And that's 2 times as many as Paul. So how many does Paul have? Well, we know that Paul has half as much as Mike. So Paul has 3 games. Okay, so we know that. we know that our solution has to come out to be 3. But let's write an equation that will make that happen. All right, we're going to first say that x represents the number of Paul's games, right? That's what we're trying to find. How many games does Paul have? So x represents the number of Paul's games. All right, so if I take 2, okay, times that x, that is how many games that Mike has, right? Because Mike has twice as many. And when I think about this, and I solve this out, divide both sides by 2, x equals 3 games, which we know that Paul should end up having 3 games because he has half as many as Mike. Mike has 2 times as many as Paul. All right, so a lot of times it's really confusing and you want to do 2 times the 6, but that would be way too many games. Paul doesn't have that many games. He has half as many. So we kind of do the inverse. We multiply the x instead of multiplying that 6. All right, so x is 3 games. Make sure on these problems you're defining what the variable is, you're setting up an equation, and you're solving it, and that your solution makes sense, and it's really what the answer should come out to be. All right, let's go to the right and take a look at this one. Janine, who bought $15 worth of makeup, spent $6 less than Leah. All right, so if we go to the store and Janine buys $15 worth of makeup, and that's $6 less than what Leah spent, we know that Leah had to have spent $21. She spent $15, but she spent $6 more than that. All right, so Leah spent $21. So in the end, our answer has to come out to be 21. All right, so let's set up x. X equals how much Leah spent. Okay, and we'll put $sign. It's how much money Leah spent. Okay, so let's think about this. An equation that's going to make us get to x being 21. Well, if I do, I'm going to kind of do this one wrong here for just a second. If I do x plus 6 equals 15, okay, which is pretty common. Well, let's think about this. If I go to solve this, I'm going to subtract 6 on each side. Well, that's not going to get me a solution of 21, right? So that doesn't make sense. So what we really need to say is Leah, okay, the amount that Leah spent minus 6 is the amount that Janine spent. So Leah spent x, 6 less than that is the $15 that Janine spent. All right, so then we would add 6 to both sides, and we see that x comes out to be 21, okay, and it is $21. All right, so always checking. Don't just make guesses. Make sure that you're really thinking about what the right answer should be. All right, next one. Nan rode the roller coaster 8 times, which was twice as many times as she rode the Ferris wheel. How many times did she ride the Ferris wheel? All right, so first of all, I'm going to say x equals the number of Ferris wheel rides. Okay, because that's what we don't know. How many times did she ride the Ferris wheel? X is the number of Ferris wheel rides. Okay, she rode the roller coaster 8 times, which is twice as many times as she rode the Ferris wheel. All right, so she had to have rode the Ferris wheel 4 times because 8 times for the roller coaster is twice as much. All right, so we've got to think about, we're trying to get something that comes out to be 4 for the solution. So again, if I'm thinking about x like divided by 2 equals 8, well, here I would multiply both sides by 2, and that's going to come out to be 16. So that's not going to work. All right, so we got to make sure that our solution works. If I do 2 times x, 2 times the number of Ferris wheel rides is the number of roller coaster rides, which was 8. Then here I divide both sides by 2. So x equals 4 Ferris wheel rides. Okay. Oops. All right, so x equals 4 Ferris wheel rides. So we've just got to continue to make sure our answers make sense. Last one, the 1,840 rock concert tickets sold were twice the amount of jazz concert tickets sold. How many jazz concert tickets were sold? All right, very similar to what we've done over here. All right, so 1,840 rock concert tickets were twice the amount of the jazz concert tickets. So x is going to be number of jazz tickets. Well, we now know 2 times the number of jazz tickets equals the 1840. All right, we see that this is multiple choice and it's not spaced out very well, but we have half of x equals 1840. Well, I know that the jazz concert tickets are half of this. So half of 1840, I've got to get a solution that comes out to be 920. Well, if I do this and I divide both sides by 1/2, 1840 divided by 0.5, That's way too many. That can't be A. All right, so it's definitely not A. On B, I would subtract 2 on both sides. 1840 minus 2. Well, that's definitely not 920 that I need. Okay, here on C, I would divide both sides by 2. 1840 divided by 2. Hey, that comes out to be the 920. Okay, here, x squared, a number times itself to be 1840. Well, the way I would find that solution is I would square root 1840. And that comes out to be 42 something. So that's way too small. All right, so it definitely can't be D either. All right, so our final answer has to be C. So being able to choose that multiple choice option is also important for us. So X equals 920 jazz tickets. Okay. Again, if you had any trouble with any of these problems, please go back, double check, and make sure that you understand everything on this page. Okay. You can also find your homework out on Schoology to do for next time.